Welcome to Just Think About It with Nadine and Ben. We're recording this episode on Wednesday, October 16th. Before we start our conversation, we have two key requests. First, if you're enjoying our podcast, please subscribe via Apple, Spotify, X, YouTube, or your platform of choice, and make sure to hit the like button. Second, we appreciate any kind notes and feedback and would appreciate you letting your friends know where to find us. So today is going to be so much fun. We're with Dave Lyons, an engineering leader, innovator, and entrepreneur who we are fortunate to call a friend as well. He joined Tesla as director of engineering as employee number 12 back in 2004, the year after the company launched. Elon Musk once said, and I quote, "Dave Lyons knew how to get shit done." Today, he leads Propulsion Systems at Joby Aviation and, in my layman's terms, a flying car company. He is a mentor advisor at StartX, a community of the best startup founders out of Stanford. He was the founder and CEO of Resharp, a knife sharpening company, a strategic advisor to Renovo Motors, a co-founder of Peloton Tech, a VC entrepreneur in residence with both Excel Partners and Claremont Creek Ventures, the VP of engineering at Glacier Bay, and a long-standing professional with IDEO. Plus an intern at Webband back in the day, if you guys remember that, and a professional yacht captain. We're not going to get into that, Dave, but very interesting with the Canada's Cup campaign. Welcome, Dave.
Thank you. Great to be here.
So before we dive into Joby or even Tesla, we want to start with your time at IDEO, the design and innovation firm with world-class mechanical engineering design. I know in the 90s, you rose up through the management levels. In your words, what were some of the greatest accomplishments and learnings from that time? Because that obviously set the stage for who you are and what you're doing today.
Wow, thanks. It's great to talk about these days back in the formative side of my career because the world was pretty different, and the foundations of what we were involved with became really mainstream. I had a love through my entire life of product and well-designed objects. I always gravitate to them. I remember people say, "What do you mean by design?" And I say, "Well, when you're going to go, and this is back in the day, when you're going to go back and you're going to shop for whatever it is and a product. Let's say back in the day it was a phone, and you would go to a place and there'd be a row of phones, and you couldn't quite read the price, but you knew the ones that you liked. You saw what drew you into that, what made you feel proud to look at that. And when you brought it home, you were like, I want this to be something that other people see because it's pretty cool. That's design, and that is it's
glasses too. I remember that.
We did glasses too, and so. We got to, back in the day, I got to be involved with a tremendous number of really hungry companies who were trying to build, great products, but they didn't have the teams in-house necessarily to do it. So they outsourced it to this group IDEO and other design firms. And I got to be kind of at the germination point of the creation of a lot of this cool product technology, and it wasn't easy to do, but back then it was still like mere mortals could do this work with a small consultancy in downtown Palo Alto and a really good set of engineering tools and not a tremendous amount of capital. So what was the most important thing about that is that we kind of got thrown in the deep end. It's like, we're going to design this cool thing. We don't know what it's going to be yet, but we think you guys are good at that. Dave, you and your friends, tell us what we should be doing. And then, as young design engineers, we got to talk to, really innovative people, Steve Jobs included, about what we thought should be done in this particular domain. And that was empowering, super empowering to us to be able to say, look, we think you should do this. And they said, yeah, good idea. And then we would build those prototypes, and next thing you know, they were in production, and then they were on the market, and you'd drive around and you'd see your stuff. And I was like, how rewarding is that? So there was a tremendous feedback loop that came from being part of that built a lot of creative confidence in me and my peers that many, many, many of them have gone on to really fantastic careers in many diverse areas. And you might ask, well, like, why can't you do that so well today? It's really because the maturity of the products has required such and tremendous capital that startups and smaller companies couldn't do it, and they chose to bring that talent in house. So Apple also brings this in house. Google, many, all of the large companies have decided that you have to staff this work in house. And so many people with my background now are in really amazing corporate roles doing the same kind of innovation. I don't know if that follows. Yeah.
I met at the Stanford GSB, and it was always clear that you were a problem solver and with an engineering mind, tied to the business world. So when you think about what attracted you to taking the leap after school to join what was the first new car company since DeLorean, namely Tesla, what was it that attracted you to that opportunity?
Yeah. Well, so Nadine, you remember quite well what it was like at that time, the early 2000s. I had gone to business school a little bit late, and I had a great run doing this design and consulting work. But I went to business school because I wanted to be part of what this big wave of what new innovation was. And there had been the dot-com bubble that burst when we were there, but we'd seen so many people thinking big and making their things big that I had a desire to do that. That's why I went to business school, to kind of remake myself, to jump into something. I had been part of a small medical device startup company at Stanford in my second year of business school, and I hired a bunch of young buck engineers right out of the engineering school master's program to work on this thing. One of those guys was this guy, Joby Straubel, and JB he later became the CTO of Tesla. He was a fantastic guy to work with. And then he called me up one day and said, "Hey, look, that medical device thing didn't have the runway. It didn't make it. But I love the way you were building teams and the way you thought about how to do this. Why don't you come over and visit us in San Carlos?" I didn't really know what I was walking into, but I got introduced to Elon, his brother Kimball, Martin Eberhard, kind of the true founding team of Tesla. And these guys were ready to roll. And they're basically saying, like, we're starting a new car company and the train's about to leave the station. JB says you're a good dude, so why don't you come on board? And I had a pregnant wife, and we had a house under renovation, and I was like, if I don't take this ride, the bus is going to leave without me. So I gotta get on. Yeah. So I went all in to do that, and it was not easy, but I have today very few regrets about making that big decision to kind of roll. And it could have been, the way it was described to me is like, it's kind of like a rocket ship. I get on this rocket ship, literally he was doing rockets, but you want to get this rocket ship, and it's either going to go way up and you're going to get a great view and it's going to explode and be fireworks, or it's going to go into orbit and you're going to not know what hit you. And we got really lucky that Tesla was the second.
And we're not going to spend too much time on Tesla today, but when you look back, I guess to explain to people what you were working on, what were your responsibilities during, maybe there was the same all the way through, but during your time at Tesla, what were your responsibilities there?
So my title was Director of Engineering, and what we did at Tesla really was to develop the new to the world electric vehicle powertrain. And Tesla's really big value add into that game was to take lithium-ion batteries, which at that point had only been in laptops. They were fantastic energy, density, and we all know today what they're all about. But at the time, you probably didn't know that. But the big idea was that you could take that many batteries and put them into small batteries and put them into a car and run an electric car with a 300-mile range, which was the big bogey for us, was the 300-mile range. Turns out that acceleration became this kind of really fun thing to be part of. But that was kind of what was driving us to do that. And my role was to develop all of those teams and from scratch. And I didn't know a thing about batteries, nor did I know about electric motors.
how are you able to take on that role when you look at your skill sets and applying it to there? Because then you're going to make this next jump, which maybe is a different kind of a leap that we'll talk about to
Yeah.
Joby,
Well,
but to understand into the mind and heart of Dave Lyons.
yeah.
You know what I mean? How was it that you were able to take on that role and be successful?
Okay. I'm glad we started with IDEO because at IDEO, we're sitting there 23, 24-year-old, smart engineers sitting up against 60, 50, 40-year-old, executives and engineering leaders telling them that we're the smartest guys in the room and how to do their products on things that we had never done before. And they knew. So so there was creative confidence that came from that, those dynamics. And another big part of it is like, you just have to learn how to get up to speed on technologies quickly. And the information is all there, really, if you just know how to look for it and how to synthesize it. More importantly, how to synthesize what you're seeing. And then maybe even more simple than that, how to decode the vernacular of what people are saying in one particular industry or another. Because so many times, especially in technology, you get people starting to throw acronyms or verbiage around that starts to confuse others. But what you can really break through that and get your secret decoder ring on, the concepts are pretty similar. And then if you try to keep a big picture on what you're trying to achieve, eye on the prize, then you can go at it and do it. And that's what we did at Tesla. And that's going to be a recurring theme going forward too.
So I know we can't keep you here all day. So we're not going to be able to talk too much about Tesla or your knife sharpening company, Peloton Tech, partners. So I'm going to move you over to Ben to jump into Joby so that we can kind of bring you out to Tesla now to Joby.
Yeah. It's pretty interesting that you're on the ground floor of the Tesla, which was, really at the time such a crazy thing. New car companies in forever. The DeLorean obviously was hella flash in the pan. And then now to be in the newest kind of new cars, the kind that go vertically up. So maybe you can tell us a little bit about what Joby is, when you joined them, your role there, and just a little broad overview, and then we'll start to dig in.
Sure. All right. Well, great. Thanks. I'm thrilled about this. So Joby is an electric vertical takeoff and landing aircraft company and airline. So not just are we developing the new to the world electric aircraft, which is essentially like a hybrid between a helicopter and a plane. We are developing that as a business model. And we're going to, instead of sell aircraft, we're going to sell rides. And so the plan is to build what we call aerial ride sharing capability, or you might call flying taxis. So many people have had a similar idea when they see all the drones and amazing technologies around. The space is known in many circles as advanced air mobility. And in advanced air mobility, when I started at Joby in the beginning of 2023, there were somewhere around 500 companies trying to build some sort of a flying car, personal drone, or flying taxi. But Joby had been really the first serious company to do this. Now, before I went to Stanford Business School and before I went to IDEO, I was at Stanford getting a master's in mechanical engineering, and I was part of a really cool group called the Product Realization Lab. And I have been involved with this group ever since I left. I mean, it's probably one of the more formative things in my life. And I've coached over there for years. And one of the guys that I coached in 1996 is a gentleman by the name of Joe Ben Bevert. And he was the kind of outstanding person that you see and you go like, that guy is going somewhere. This guy is someone I want to keep track of. He's very impressive, but very, very personable. So I have kept track of him. When I was done with Tesla, I reconnected with him, and he was courting me to join him. And at that point, he was building something called Joby Energy, which was airborne wind turbines. And so there was a 5 or 6 companies in that space. They're basically electric planes. And he had essentially he called it an engineering commune in Bonnie Doon, about 10 miles north of Santa Cruz in the mountains where he came from. And they had a giant quarry that they were doing all this work in, and a bunch of, really great engineers, young engineers living on the property. And so they morphed that in about 2015 into Joby Aviation, where they're building the first the first generation of this 5-passenger electric vertical takeoff and landing aircraft. So I can tell you more about it, but
yeah. So before we get into the details, because I do want to ask you some stuff about the business, let's just start with, like, in a layman's term, how do these things fly? Like, what is the, like, how do we just boost up like that? Maybe give us like a little overview of the physics on it.
Yeah. All right. So there are 6 propellers or 6 rotors and 6 engines. They're electric engines. We call them electric propulsion units, and they're on tilt axes. So when you come to the aircraft, they're all pointing directly up to the sky. They're in an array like you'd see on a drone. There's 6 of them in essentially a squished hexagon. There's a pilot and 4 passenger seats. You would get in the aircraft. It would immediately power up, lifts off, gets about 20, 30 feet off the ground, and it'll start to redirect in the direction you're going to fly. And as it continues to elevate, the rotors will start to go from vertical to forward. And then the plane has a wing. And so by the time you get to the elevation that you'll probably cruise at, which is maybe between 5,000 and 10,000 feet, you're flying like an airplane. And it's a 6-engine orientation where all the engines are now horizontal. So you're flying about 200 miles an hour. There's about 150-mile total range, and that's with all battery. And then when you get to where you're going to land, it kind of reverses itself and transitions back to a helicopter or a hover configuration, and it'll land vertically. So it's so the idea in the business model is how are you going to make money at this? So the idea is that you're going to sell rides over congested metro areas, New York, San Francisco, Los Angeles. Those are metro areas that we have now under our system, and the idea is that you'll call with the Uber app, you'll call for a ride, and then a car will pick you up where you are, take you to the nearest skyport, which is essentially like a heliport. There'll be an aircraft waiting. You'll get in the aircraft. You'll fly probably in a hub and spoke kind of model to the airport, and then we'll drop you off at the Delta terminal, and you'll go on your flight, and you can back off the same way. If let's say you're in Los Angeles and you were in Palos Verdes and you wanted to go to the Lakers game on Friday night, you might take that ride up over the Los Angeles traffic on the 405, and then land downtown Los Angeles, go to the game, then back it off and go back home. Again, passing over 2 hours of driving something in a flight's maybe 10 or 15 minutes max.
Right. So my first question is, well, we have helicopters. Why are we replacing helicopters?
Probably
what's the compare and contrast, I guess.
Multiple advantages over what we do. First and foremost is quiet. We have 6 rotors, and it's amazingly quiet. So, and in cruise, our aircraft is quieter than an F-150, Ford F-150 pickup truck. So that's a gasoline F-150. But still, they're incredibly quiet. You all know that helicopters are not. So that means that we can land and do operations in areas that would normally have real problems with noise. And you require noise abatement. So noise abatement is a big issue. Redundancy is another big issue. The fact that we have the 6 rotors, and from first principles physics, we've designed multiple redundancies of safety. And so the idea is to build a very, very safe aircraft. So helicopters. All aircraft are, inherently potentially dangerous, but we're also given the advantage of being, starting this business in the late 20 teens, where so much engineering has gone into the ability to control these systems that didn't exist for most of the aircraft that were developed in the past. And so the legacy systems are going to struggle to have the capabilities that we have because we started from scratch at a later date.
And how much land do you need, to take off and land versus a helicopter pad? What is
exactly the same as a helicopter?
it?
Yeah, no different. So you need more than you could land in, maybe in your backyard if you got a big backyard. But our plan is not to do kind of regular random landings. That we're going to still take off probably from things. Obviously, airports and small regional airports like Palo Alto Airport or San Carlos Airport would be great. But also in more urban settings, the tops of parking garages are very, very common because A, you don't want to park on the top of a parking garage, so they're often underutilized. And B, they're already there. And so those are thoughts. Yeah.
So okay. What about on the manufacturing side? Like I'm looking at one of the investment bank's models of your company and talk about the cost curve, where it's come from, where it's going to go to manufacture one of these at scale.
Yeah, right.
And maybe compare to what a helicopter would be also.
Yeah, right. Well, so a couple things first thing to, and that really attracted me personally to Joby and to this team is that there's a lot of lessons learned from Tesla. Tremendous number of lessons learned from Tesla. Many of us have deep Tesla backgrounds. And the lesson that we learned, and Tesla learned the hard way, was that if you want to do something this innovative, you have to be in control of your own destiny in terms of vertical integration of manufacturing. And so from the very beginning, JoBen Bovert has been really keen on making sure that we design everything ourselves from first principles and manufacture it ourselves. So we're in charge of our own destiny. So that means in the beginning, it is harder to do this because you have to set up that entire ecosystem if you're going to set up all of those CNC machining centers and operations across the world. But we've done that. And so then when you do that, after those kind of initial investments, you now have the ability to kind of create the right-sized components under your control and your timeline in a way that gives you strategic competitive advantage. So unlike our competitors who have decided they're going to do a lot of partnering in the tiered aviation industry, tier 1, tier 2s, when you work that way, just like Tesla did, you can run into a lot of challenges because there's misalignment of incentives. There's also delays that are out of your control from their other customers that don't allow you to be as nimble as you want. So we see it as a strategic advantage to move forward this way in the beginning. And hopefully that answered your question.
And so do you have all the manufacturing facilities or what is it you do?
Yeah, so we have right now, we have all of our engineering and business operations are in Northern California. We're based in Santa Cruz. We have operations in Bonnie Doon still. We've essentially taken over an airport in Marina, California, which is just about Monterey. That's where we build the aircraft itself. All the carbon fiber layup and all the aircraft assembly and integration is down there. Flight testing is down there. And I work in San Carlos, California, where we build everything that has an electron. The propulsion units, the electric motors, the battery packs, which are very proprietary, and all of the electronics that we've right-sized for this type of aircraft, rather than buying bulky kind of standard object things that you might find in, say, a 787. That's too large and bulky for us. We don't need that. So we basically re-engineered many things ourselves. That's in San Carlos. We have an operation in Shenzhen, China, which is unbelievable to actually machine and make most of these parts. And then we've just a year ago announced a large facility in Dayton, Ohio, where we're going to build at scale. And maybe I think, a really, really important point that I love about what I'm doing at Joby is that our largest investor is Toyota. And they not only have invested $900 million into Joby, but we have 200 senior manufacturing leaders from Toyota embedded into our teams to help coach us on how to do the Toyota production system.
Just announced that they're investing another $500 million in Joby. So congrats.
Thank you. And I love getting to know these Toyota people. They are fantastic. They know their business better than anybody. If we had this help at Tesla, we would have been like those 2 or 3 year delays on those cars would never have happened. These guys are awesome. So I have embraced that, and I personally spend most of my time working with the Toyota team.
And so now all right, we have these cars or planes, whatever, hovercraft. How long are you guys thinking that they will last, like for a useful life? And then also talk to the life of the battery as well.
Yeah, good questions. And with regarding the battery life,
okay, that's fair enough.
It's certainly a huge part of what we study. We've got large rooms full of battery cycle testing, and we have battery relationships. We don't make our own cells like Tesla yet, but we have relationships the batteries that we have are bespoke to us. And then they're basically building to our specification. And when they reach the end of their useful life, we have secondary uses for them in our charging infrastructures. So since we're doing the entire ecosystem, we can put those batteries to use for fast charge capabilities, basically for buffering for fast charge. So that's kind of one of the cool things about that. The aircraft themselves, they actually should last a large number of years in their economic life. But since we don't sell them, and we're building this entire own and maintain fleet of aircraft, that really becomes our own kind of fleet management questions. And so we don't have to. And then we also, in that same game, we warranty them ourselves because we have this. So you take a lot of the different transactional aspects of selling an aircraft to an airline, and make those, an internal problem rather than an external.
And then what about the natural other issue? Like, who's going to pilot all these things? I mean,
excellent question. And if we put this many aircraft in the air, where are you going to get the pilots, right? So, our COO is a woman by the name of Bonnie Simi, and she is really an amazing individual. Not only is she a 3-time Olympic luge person representing the United States, but she was a long-time pilot for United, and then she worked at JetBlue Ventures. So she immediately said, look, what we need to do here is we're going to build our own flight school. So we're basically going to build the capability to homebrew our own pilots, and go into the vocation of pilot training for our aircraft. So hopefully that we can match the aircraft production and the pilot production at the same time.
Right. And then so the last thing on the cost side is how expensive is the insurance? Is it the same as helicopters? Is it going to be more because it's new? Like, how do you price that risk?
That's an excellent question that I honestly have zero visibility into. Yeah, I got too much work to do on the engineering to do that. We have a great finance team that our CFO Matt Field was CFO of Ford Motor Company, and he was fed up with being in Detroit and the Detroit ways. So I'm going to let Matt take that one.
Yeah, that's totally fine. I'm just thinking it through in my head as we go, and then so maybe talk to okay, it's a 5 or 6 person seat, and so you're basically in the business of selling capacity of seat miles times the utilization of the fleet, and then whatever the price per mile per variable mile is. Is that kind
That's
of
right. Yeah, that's exactly right. And so that's why we want to go to congested urban environments first,
Yeah.
where the we believe there's a latent demand for this kind of work.
Density? Yeah.
Now there's density there. There's premiums they're being willing to pay, especially kind of first degree price discrimination. Like, hey, when the unit first comes out, we're not going to be at the the low cost provider, but many people would go from Midtown Manhattan to LaGuardia in 7 minutes. So if you could, and I mean, you can today. We all know that. I mean, that there's helicopter service, and it's probably not as well utilized as it probably could be. But we want to basically find ways to make that much more compelling.
And
Yeah,
what
there's
is weather? I mean, does it work in the snow and the rain, or does it have greater, or is it time greater issues than a helicopter would, or how do you compare that?
That's an excellent question too, and that's a big part of what we do in all of our endurance and durability testing. Try to understand exactly how and when we would reach the extent of our flight envelope,
Right.
And make sure that we don't put ourselves into situations that we shouldn't be in. So I think, I mean, obviously, we're like right now we're in the middle of things like doing lightning strike tests on our whole unit to see what exactly are the failure modes when that happens. And obviously in worst case, one of the most important things that I have learned in my journey here for the last 21 months is we are in the kind of the last 30% of what it takes to get the FAA type certification approval for an aircraft, a new aircraft. And that's really challenging to do, not only because are we in kind of a new, like electric aircraft haven't been type certified before, but vertical takeoff and landing aircraft for commercial use have not been type certified before. I mean, obviously we have military, but not commercial. So we're in kind of two new categories. And so we work really closely with the FAA. And the way I describe it to laymen is that when we're working with the FAA, it's kind of like they want to make sure that everything is safe and that we've well thought through things. And at the end of the day, we have to agree, say what you're going to do, and then show us that you can do what you say and demonstrate to us. So we're working with them on all the details of that so that all the I's are dotted and T's are crossed for safety. And that's what we do is we brainstorm a lot of corner cases. And trust me, the FAA can come up with all the corner cases. They know what's going on. So, but they have been great. They have actually been great partners for us because they want to see the United States lead the world in advanced air mobility technology rather than become laggards in this. So we have had tremendous bipartisan support for this space. Right now, Pete Buttigieg is director. He's Secretary of Transportation, which is in charge of the FAA, and is very bullish on this. And so we have seen nothing but support, but it's also trust but verify is a big part of this.
Will these be able to land on helicopter or on the tops of buildings the way helicopters can?
If you have the right area, if it's a large enough area and you don't have antennas and things that are in the way.
Yeah, I mean, I remember being in Sao Paulo for business, and like that's how they get around down there. Like literally everywhere is this helicopters going from building to building.
Yeah. Yeah, I mean, Bernie Madoff had his own seaplane, right, just to get himself to the Hamptons every night. So, there's demand at the right level for these kinds of services, I believe.
Well, and what about the other use cases? So, rescue, like that seems like a natural one. And then, is there a point where recreational guys who are rich are like, hey, I'm gonna go fly my car around?
I think the third case you're talking about there. Well, first of all, rescue for sure. We haven't talked about military, but military is actually a big part of where our funding comes from as well. The Department of Defense. We have 2 aircrafts in our first 10 allocated to deliver to Edwards Air Force Base. One is down there right now. And then, but our competitors are actually in that game of creating kind of toys to sell. I'm not sure if we would go there, but who knows? If production capacity is there and we can figure it out, then sure.
Because you've mapped out the economics and you think it's the Uber model is better, or what? Why are you saying that? Is it the regulations are different, or?
I think it's the economics are far better, Nadine. I think ultimately it's not scalable to build toys for a small number of pilots. We don't want to be in the in the Cessna space, right? We want to be in the I guess Waymo kind of space, or Zoox or something like that, for selling rides into a custom vehicle.
Yeah, my friend Heather was selling submarines for a year or two, and she said it was very difficult. You have to find these people who are very rich and can afford those things, and then you make a one-time margin on the sale. It's not as good of a business. It
didn't do so well a year ago when they went down to the Titanic, did it?
That was a competitor of hers, but she said it was very difficult to sell subs after that experience.
I would definitely short that market at that point.
Well, needless to say, she's not doing it anymore. But okay, so
that's
then
still interesting work, right? I'm sure that they had some fun. There were some fun days in that game.
Yeah, for sure. Okay, so let me ask you on the strategy of this then. If we're going to be an airline, is it going to evolve like the airlines where you're going to own routes in essence, and you're just trying to get a real estate grab? Is that the way you guys think about it?
And the grab has already occurred.
Okay.
Yeah. We don't have Chicago, but we have Los Angeles, San Francisco, and New York.
Okay.
So we that, but so that's going to be complicated, and we'll see. Right now, just to be really candid, is that we have 3 or 4 competitors. I don't want to mention them right now, but we have 3 or 4 competitors. Very easy to find, and their things. Some of them look a lot like ours. They're fast followers. It's really going to depend on really. If you get there first and established, I mean, some of those land grabs from early days can be renegotiated, I'm guessing, right? Like if we don't do a good job to hold on to our markets, that won't help us.
So, David, you're going to Chicago, you're going to LA. Who are you negotiating with? The mayor? Is it the state? Like who are you negotiating?
I wish I knew. I think it is that. I think it is. I think a lot of these large it's really around airport rights. And I think the large airports are controlled by the city, county, and states, depending on where you are. So I know that, and so there was a very interesting set of land grabs. I mean, I'll say, so Archer is our biggest competitor out of Palo Alto, and they're good guys. They're very smart, and their plane looks again a lot like ours. We are aligned with Toyota, we're aligned with Delta Airlines, and we're aligned with Uber. And we have equity investments from all of them. Archer's aligned with United, Stellantis, and I don't think they have a rideshare company. I don't know if they're aligned with Lyft or not. That's a very good question. Yeah, I'm following close enough.
Isn't a good one.
Because of so Archer got Chicago. I think again before my time, but I think because of the United and we're with Delta. So.
Yeah, I mean, so we're talking about the air rights for a second there. I know that Amazon, with one of the complications with the drone delivery is that some people have the air rights above there and they won't let you go above it. Like, will you have the same kind of complications, or?
When we start to, like, I'm only speculating because I really haven't talked to anybody within Joby about all of this. So I believe that we're going to follow kind of standard general aviation, commercial aviation air routes. So most of the time we'll be taking off from things like airports, going to other things like airports. And so the routes aren't going to be more randomized. They're very pre-described. And we'll file flight plans with the FAA. We'll have, licensed FAA pilots and great communications. And we're working really hard to make sure that we're being really great citizens of the sky.
Yeah, and will that integrate naturally with the other helicopters and other flights, planes? Was that, or will that take some engineering work to meld the systems?
Well, I think there's definitely systems engineering work that has been in the background for a very long time with the FAA, and also the DoD regarding kind of airspace management when you have a tremendous number of flying objects in the sky. And so some of my MIT classmates still to this day are deeply involved in kind of the world of managing these airspace in a 10 or 100x more aircraft. So I'm assuming that we'll just be part of that kind of growth path, and it has. But the good news is that a lot of very well versed and smart individuals have been spending time thinking about it.
And when, one of the things you had mentioned is working with the FAA has been like helpful because they've got the corner cases. In 2023, Joby signed a big contract with the U.S. Air Force, $131 million. And as you said, delivered a first vehicle to Edwards Air Force Base. You're also working with NASA. And when you're working with these sorts of organizations, do they affect design and engineering for what you're building? Or like, what have you learned from working with them? Like, are they giving you use cases, not just the coroners, but are they giving use cases, or are they bringing insights into the engineering aspect to it, or what are the biggest impacts?
I think all of the above. And it's not so much in the corner. So what they're really helping us with is try to understand on the vehicle side, systems engineering, and helping us really refine how to structure the requirements by which we're going to have to test to and then build the aircraft to. And so their insights, because again, NASA and a bunch of the work that had been done that way, that in the military across the board, they're the true experimenters in aviation, right? They're out there. They've tried things that we can't even imagine and in stealth situations. So their teams kind of know areas of fertile ground for potential next commercial aviation technologies. And in these partnerships, that collaboration is quite valuable to us.
And so
then they bring tools
to work with you that explain it. Are they giving you documents, or how does that mind share or experience get translated over to you and your team?
Well, for example, NASA. They have here in Mountain View, California, they have the largest wind tunnel in the world. And it's called NFAC. And basically, although we had to pay rent, they allowed us to have that for the year of 2023. And we're going to get it back next year. I don't know what the date is, but allowing us to get to use the sophisticated tools that cannot be recreated by anybody else. This is the best in the world. And then as you sit with those teams for a year, there's a lot of sharing.
Sure.
There's a lot of synthesis and synergy in there.
And I want to get to, there's a lot of excitement around this, but I can imagine too, there's a lot of naysayers and pushback, right, from a whole host of constituents. And
Sure.
So when you look at the greatest concerns, because you could say, oh, maybe this is just rides for rich people, or it may not be their toy, but it's a toy ride, if you want to say it. You mentioned a bit about noise pollution is something that you've worked to counteract. But maybe walk through, I don't know whether it's energy, infrastructure, environmental, maintenance of facilities. What are the biggest pushbacks that you get from people?
You touched on many, that's for sure. The
I can guess.
She's big basket. Here, give us it all.
Yeah. Really like a village idiot one I didn't think of.
Yeah, no, this is fantastic. The I think that the first thing that comes to mind when you say that is that the things that people told me when I told them I was going to start this new company called Tesla, and many like many of my really smart and well-respected friends, like when I went to breakfast with them back in 2003 when I joined, it was kind of like electric dragster. Like, who the hell would want that? Like, what's that? Like, what kind of wet dream is that all about? Like, sure. The other one was like, that's going to be like, this came from a very trusted venture capitalist friend of mine. And I shared the business plan with him, and he was giving him advice. He goes, Dave, this is going to be a really great project for you. Yes. But just be clear, you're not going to make any money at this. But you'll speak for you, though.
Some experience.
So that individual will go nameless. But
somebody who was early at Amazon, they were telling me about selling books to the mail, and I was like, "That's stupid."
Sure. Yeah. Exactly. So who knows? Whether I believe that an infrastructure-less solution to congestion in the next 50 years is going to be really important. And the only way you can go is you might think you can go down and through. You can. And Elon has started to do that. I've been in his tunnels in Las Vegas at the CES, but that's never going to work. The Hyperloop is never going to work. Because you can't, the United States can't deal with these large infrastructure improvements.
Put telephone poles on the ground here.
Well,
yeah.
The best example of that was I lived in Boston after grad school, and they were like on year 20 of the Big Dig or whatever.
That's a great one. So I finished MIT in 1987, and they were like, we're going to do this amazing project, and it's going to be 12 years. I'm like, I went to my 30th reunion, and they were like, grand opening.
Yeah, it's exactly. I think it was like 20 years plus ago that I graduated from grad school, and I was there, and they were just finishing up or whatever. It was just like
crazy.
Yeah.
And it's beautiful. I mean, I'm going to go to Boston this weekend for my kids, and it's but man, like you can't imagine. It's like we're going to grow fast, and the congestion is not going away.
Correct.
And I don't believe, and I spent a decade doing it, that autonomous vehicles will solve that problem. In fact, I actually believe it might make congestion worse.
So
why is that?
We want to know. So why? Why is that?
Why?
I think that when we all go to if you go to autonomous ride sharing, I think those cars are going to be blocking people. If we all start adopting it more, there are going to be more situations where they're stopped in the lane in San Francisco and you're trying to get around them, or they're in a situation, right now, the classic one is, someone put an orange cone on it or got confused, it stopped, didn't know what to do, whatever. I just believe that it isn't a congestion feeder in the grand scheme of things. Because if you say it's your individual car, it's still an individual car. I mean, it's just I think it'll be safer, guaranteed it's safer than not. Some people will fight me on that one, but I believe autonomous vehicles are way safer. But congestion's, it's just so impactful to your life. And when people start to say, then I can't get to where I need to go, or that's 2 hours to do something that would take me on a Sunday morning at 8 a.m., 25 minutes, that's, it changes your options, right? So aviation, I think, going to this other plane and many planes above it, so to speak, I was talking about like airspace planes, gives you optionality that we just don't have. And when that's unleashed, I don't know how many more people will really start to understand kind of what's possible with that. And I'm right now, and again, just sharing my personal situation here. The reason I'm at Joby is that it's just too cool to not be part of after all the things I've done. And I'm like, I know the founder, I've known the guy for 28 years. Like if I didn't, and he offered the role to me in 2010, if I passed on it then, I had one opportunity to get back into it, I wanted back in.
Yeah, and it seems like you're hitting the accelerating point right here. So how many planes do you guys have right now? Like 50, 40, 50?
No. We have, we've built 8.
Oh, you built 8.
planes.
Okay.
And we're continuing to build at a pretty good prototype rate. So these are pre-production planes.
Okay.
They're exactly the same as we're going to put people into, but these are the ones that we're going to let the FAA take over and do all the serious testing to make sure that they believe that we said that we're doing what we said.
Okay, so I'm looking at the model. So most of these planes are for the Defense Department so far.
No,
They have
just
been
two of the first 8 were supposed to be for Defense Department, but this 6th, 7th, and 8th have not been delivered yet to anybody other than ourselves.
And what's the capacity of how many can you build under your current capacity?
Current capacity is very prototype. We're on the order of a low integer number per month.
Okay.
But that's what our Dayton, Ohio facility will be able to. Our plan there is to ramp up with the help of Toyota, which is fantastic, to get to 500 and then eventually 1,000 per year.
Okay, so then is you.
So Ben, before we go into the numbers, can we talk about the convergence of technologies that's supporting what you're doing? So direct electric propulsion, special electric motors. What are they? Why are they important? So I got a list of a few of them just so we understand the tech that's in what you're doing.
Yeah. Well, like I said from the beginning, the first principles physics approach is really the key to Joby's advantage, I believe. And then the ability to then build it all ourselves so we don't have to rely on other people to do innovation. We do the innovation ourselves. Now, in terms of the electric powertrain, so the battery and motor technology, we have these really sophisticated levels of redundancy. For example, every one of first of all, if our plane were to lose, first of all, you have 6 rotors instead of a single rotor on a helicopter. We can lose up to 2 as long as they're on opposite sides of that. And each motor itself is actually something that I had never really come across before, which is called a dual wound motor. And that means it's essentially 2 motors in one. And there's full redundancy on its motor controllers. So imagine the motor has you cut it in a slice of pie, it's 6 slices. And one slice is motor A, there's B, the next one's motor A, B, A, B. And now, when you're running in regular operation, they're each running a completely isolated and separate controllers and battery pack systems. So when you are regularly running, you just send the same signal to both, and they run like one motor that's twice as big. But if anything in that system fails, you lose half of it, and you just turn the other one up for the short term to bring it down safely, or you turn it off and then you fly on 5 or 4 in that situation. So there's that level of redundancy is fantastic. So the motors also, because mass, weight is so critically important to an aircraft because it much more directly affects range and electrical efficiency than it does in a car. The premiums that we pay to get to really lightweight, strong materials, so that the density of the power that we've delivered to the rotors is we pay a very high premium to do that. But that allows us to buy really sophisticated materials and very sophisticated processes that electric vehicles just can't afford. You just can't this is Formula One level technology that goes into each aircraft because at the end of the day, aviation stuff is much more expensive, but you pay a premium for it by the ride. So I think that's where the devil's in the details of running the business models. And I can't get too deep into all that, but at the end of the day, we're working on these really sophisticated motors, battery packs integrated into planes in a way that are very lightweight, very aerodynamic, and very safe.
And so environmental. I mean, you're actually hitting through some of my bullets: motors, batteries, materials. I got a couple more, but going back to the batteries, are there environmental and energy concerns here?
Environmentally,
I mean,
none.
Right.
0 emissions. That's what's so cool about this. No emissions.
is that last, and then but you said that you get to use that in your charging stations, or or whatever you're doing with it. So, because that's, I think, one of the knocks, right? Is that great? We have EVs, and then what do we do with the batteries, and where are those going?
Right. Yeah. And I mean, those issues are big, and there's multiple sides to that, right? And we all get there's a lot of naysayers in electric vehicle technology, whether aircraft or planes and cars, but that like look at all the costs of mining the lithium and all the costs that go into the energy to make the batteries instead of but at the end of the day, the electric propulsion systems and on a per unit basis are incredibly efficient. Like, I don't actually have the numbers on aviation in my head, but I do have them from Tesla. But like if the equivalence of miles per gallon of a Tesla compared to regular cars, like they're all like around 100 miles a gallon equivalent for the motive force with energy that will be converted to make that electricity. And it's probably equivalent. So like if your car gets 25, so it's a 4x improvement in the general unit efficiency. And then you can argue that, that electricity has to come from somewhere as a clean, whatever. But since we're really talking about a pretty small amount of electric energy in general, because we're not talking about a large impact at this point in aviation, but what we are talking about is zero emissions. And most people are not really talking about the actual emissions that come from jet engines and from internal combustion engines in the sky, and they are not particularly clean. So every time you see a jet go over, there's a large contrail behind it. It's like, that is not necessarily good for the environment, just to be clear. But we value air transportation so much that it really hasn't come into the national dialogue, the national narrative yet about how dirty aviation is. But we believe that that'll change.
And
Although it does,
because everyone gets riled for taking their private planes to Davos, right?
Yeah,
exactly. Right, exactly.
The Davos guys get kind of a rough time trying to tell everyone about the environment while they are the biggest carbon emitters.
I would fly to like Austria and then just take an electric train in there or something. I have never been invited, but if I did, that's what I would do.
And just a couple more here is, can we go into sensors? Obviously, for safety and mechanics, there's going to be a lot of sensors in these. Maybe walk through what type of sensors are used for what purposes.
That's what's beautiful about, again, being part of this new wave of technology, is that we are able to leverage so much in the advanced technology in terms of sensors, as well as just general electrical components for EV technologies that have now evolved over the last 20 years. But everything we do is very well engineered with closed loop control. So just for not to get too technical here, but open loop control means I kind of have a throttle and I push down on it, and then the car were to accelerate to that. Closed loop control says it's more like cruise control. I set a speed and then it manages the throttle to get to the speed we want to control. And that's because you sense everything along the way, and then there's intelligence in that process.
So you're setting me up here. So for the computational or AI or whatever you're using, how important is it to integrate that data for safe flights or for other uses? Maybe being, as you're saying.
That's an excellent question that I got in self-driving all the time as well. Like this must be a lot of AI. And the truth of the matter is, what it really is really well executed classical engineering controls with great computational power behind it. Okay. So high resolution sensors, and then classical control, because that we know that works. And then artificial intelligence, I guess I'm going to be really open. I don't know how impactful it is on our aviation right now, because one of the challenges we face, again, with the FAA is that you have to prove efficacy to like beyond a shadow of a doubt. And if you are in an area where you're starting to take a leap of faith in a new emerging technology on a safety critical system, you've got to make sure that you can demonstrate that you have 100% confidence in that. So I expect that will come with time. Autonomy will come with time. We've built a lot of autonomy. We just announced in June an acquisition of an aviation autonomy company called X-Wing. And that's really there for us to look at. We're looking beyond this first offering, the S4 plane, the ride sharing, into next generation technologies. But I can tell you right now, and cut to the chase, where is that going to be? What's going to be the big hitter? It's going to be hydrogen fuel cells, and that will give us the ability to extend the range. And we're going to be able to go from being a metro area kind of hub and spoke model to regional aircraft. So to fly from San Francisco to Los Angeles on a zero emissions aircraft.
And what do you think the timeline is on that?
Well, I can't disclose, nor do I actually know.
Yeah.
But what I can disclose is that over 4th of July, we converted our serial number 5 aircraft we acquired a company called H2 Fly, a German aviation fuel cell company, and we integrated that technology into our aircraft, and we flew 523 miles in one flight.
Wow.
Whereas the previous record was 150 miles, and that was from us as well. So we have a roadmap there that looks very promising, and again, that came off without a hitch. So that's essentially liquefied hydrogen being put into obviously a hydrogen storage tank on the aircraft. That's always brings up these kind of Hindenburg level of concerns, but there's a lot of safety systems that go into this.
Yeah.
You're going to see hydrogen in long haul trucking become much more important. It's in cars today. So there's a lot of people looking at safe hydrogen from, not 100 years ago. And one of the more interesting things about that is refueling time. So batteries only accept charge at a certain rate. So you can put larger and larger batteries in to get more and more range, but at some point then it's a diminishing returns because of the mass of the batteries is very much fighting you in terms of the energy density of the aircraft in general, taking away from your payload, but also then it takes a long time to recharge those batteries each time, where is hydrogen pumps in at the rate gasoline pumps in. So
can I come back to you saying at one point there was 500 companies trying to make that? And that reminds me of reading stories about the 1910s and 20s where there was hundreds of new car companies, and then we whittled down to 4, 3 in Detroit, and then Toyota, a handful of companies globally.
Yeah.
Do you see it playing out like that, or do you think it'll be a more fragmented space, and how do you become the winner in this space, I guess?
Well, I think it's going to play out exactly like that old automotive analogy. And I believe there's going to be tremendous fallout and consolidation. I'm sure there are very talented engineering and technology staff at many, many of those companies. I'm sure that they've come up with some ideas individually that are well thought through for their particular application. Those companies might be more valuable than others, but they might have not put the whole pie together. And Joby is working really hard to be the leader in this space and thinking really big and broad at the same time as our competitive advantage, that we're trying to build everything so that we're not leaving our success in anyone else's hands.
And I think just around for people, though, is that the ticker is JOBY. It's a U.S. company, went public in 21 for $4.5 billion. Obviously considered to be one of the closest to bringing this type of solution to market. And in 2022, one of the first firms to receive the U.S. airworthiness certification. You said, backing from Delta and Toyota. and we're not here to I guess mark your competitors. You mentioned Archer. They also went public via SPAC and have orders dealing with United. They've got UAE, Interglobe in India. So it seems like there's partnerships. Obviously, capital is very important. So I'm not going to mention the Chinese, all the other companies.
Oh, yeah.
I want to give you the background that you guys, there's a couple folks that have gone public so people can get a little bit more information if they so choose.
Please, Chad, go learn. And it's really hard. In my case, it's interesting because I actually, and this is something I learned after Tesla, is that like I spent so much time at Tesla worrying about what each one of the competitors was doing while I was doing it. And I think it distracted from me actually doing the work at hand. And at this point in my career, I am focusing far more on just making sure we're executing really well on the mission that we've already stated. And then again, I'm not saying that we will succeed, but I placed my bets with where I chose to work.
Yeah, and how about this, though? Let me ask you one more thing on this. So you think about the airlines evolution, you have two major global manufacturers that all the carriers buy from, right?
Right.
Could you see something like that where, like, hey, the Brazil guys there's a carrier for Brazil, and there's a carrier for Korea, and a carrier in some leader, maybe one or two or three, whatever. But then there becomes, maybe it's you guys, the best tech, and you have Airbus and Boeing again.
Yeah. Yeah. I don't know if it's going to play out that way or not. Like, would we become essentially the supplier to multiple airlines globally of aircraft? I wish I had the answer to that. And I wish I was at a board level, and I'm not. So I don't. And if I was, I'm not sure I could necessarily opine. But the interesting thing there is, I think it will be Wild West for a decade or more. So
Yep.
I don't think it's going to be clear, and I wouldn't want to place any bets on a 20th century business model winning in the 21st.
Yeah, that's interesting. And then is there the Chinese? Who are the big Chinese competitors?
I don't follow them at all.
Okay.
I just see people send me videos, all the time. Hey, Dave, I just saw this. What are you guys going to do about that? I'm like, I'm going to keep building my aircraft.
Good. It's good. No, head down.
Yeah.
Let me ask you one more thing on this. What do you think about drones? Coming back to it. I mean, these are kind of like big drones. I mean, you guys, drones for delivery, that helps with the decongestion problem, right?
Yeah.
And now I know the military, it's like all in on drones now.
Oh, and and it has been for a long time, and I think that proves that there's true merit there, right?
Yeah.
This whole idea. Like, by the way, anytime you see a Joby video where we're flying the aircraft, it's being flown remotely by a pilot in a container nearby, just like any military drone is. Because we don't put the pilots into most of we have flown piloted before, but we currently fly everything at the FAA's request, remote piloted for safety, just to be that way. So,
So do you have passengers in the plane, or just nobody's in the plane?
No one's in the plane yet. We have not gotten FAA approval to put passengers in an aircraft yet. And, we're rule followers. So we're going to continue to keep doing that and we're just working down that path to make sure that we follow everything that we're supposed to follow to get this aircraft to be safe for passengers. Because the last thing we want is to go off and have, a high profile incident with a passenger that takes the entire industry down. Now,
like the submarine
from a competitor.
It's
and
this is like the submarine in the Titanic.
Exactly. Yeah.
Yeah.
No doubt. So in drones in general, and drone delivery, people like Zipline, they make a lot of impact. They could very well do well. I think there'll be use cases that are more appropriate that'll probably take off first. I don't see it being, Midtown Manhattan kind of way to get your stuff delivered to you, or it may not even be a suburban Palo Alto way to get your stuff delivered to you. I mean, I'd be open to it, but we'll see.
And let me ask one final question or one final topic. We can see if it goes. As a guy who's an engineer and a designer, what's your thought about, the Archer CEO's new company, Figure AI, and some of these robotics companies? I know Tesla just had their event and there was dancing robots. And what's your thought on the evolution of robots and the use in society?
Yeah, man, I'm impressed. I'm very impressed by what they're able to achieve as an engineer. I mean, I was also extremely impressed, by the way, with Segway. I thought Segway was fantastic. And there was a tremendous amount of hype, as you may remember, around the launch and the secrecy around the launch of Segway, and like, look where that went, right? But that takes nothing away from the technical prowess of the individuals involved in that. So I'm extremely impressed, even if the Tesla one was really puppetry, which what I understand.
It was terrible to learn that, wasn't it?
So, I mean, they did it before. Didn't they do it once before? There was actually like a human in a suit.
Oh God,
it was ridiculous, right? Like that they would try to pull that one off. That's like, that's bad. Bordering on, that's problematic for me. The use scenarios, the value propositions, I've yet to fully understand it. All I know is these things are not going to come cheap.
Right.
These things are not going to come cheap. So I think I just have to better understand what the application is. If it's industrial assembly, I mean, regular 5-axis robots are really cheap compared to those. So I don't fully know
where this all going
yet, how it's going to roll.
Well, thank you so much, Dave. We may have to get you back on the podcast because I feel like we've just scratched the surface on so many topics. Thank you for sharing your wisdom with us today. And if our listeners want to connect with you or hear more about Joby and your work, where can they do that?
You can reach out to me directly in my email, dlyons@gmail.
Awesome.
dlyons@gmail.
Thanks. Thank you so much.
Thanks. All right. It was great.
Thank you.